Hi everyone, welcome to a new devlog. I have a lot of exciting news to show in this episode, so let's get started. From the beginning, I said that I wanted to include firearms in my game. Even though they are not primary weapons, they have a very strategic role when facing certain enemies. So now the player can equip melee weapons and firearms, and equip them as primary or secondary weapons. The UI design is temporary, but already includes all the main functions and support controllers. On the other hand, I have included physics with constraints when equipping weapons, so they hang from the sockets and have a more natural behavior when reacting to the player's movement. Also, on an aesthetic level, it gives a more polished finish to the game. The physics in UE5 is quite bugged. If you encounter unexpected behavior, version 5.1 fixed all my problems, in case the same thing happens to you. Another challenge I encountered was with the aiming. The most common solution is to project a raycast from the camera at a certain distance just in front using the forward vector. This method, however, is not accurate if our camera has an offset. In any modern game, the camera is not in the center of the screen. There is always an offset from one side or another. To correct the offset, I use two raycasts. The first is as I have described previously, and the second is from the player to the point of impact of the first raycast. With this method, we have more control and precision over the impacts. In addition to shooting, the player can reload automatically if there are more bullets in the inventory. I still have to design the UI that communicates all this, but I'm pleased with the progress of this new mechanic. The available firearms will be blunderbusses and other medieval weapons that can be bought, looted from enemies, or found in the world. Finally, I have also included the possibility of a lock on target or auto-aim. This already existed with melee attacks, but now we can also use it with firearms. On the other hand, I have started to replace the level blockout with definitive models. Level design is one of game design's more complex and overlooked aspects. I have much more appreciation for level design now that I'm designing my own levels from scratch, not only from the gameplay, but from the technical point of view of asset creation. Games like Uncharted, Last of Us, God of War, and The New Hogwarts, to name a few, are breathtaking. With their quality and level of detail, the hours and amount of people who have worked to create those levels blow my mind. Of course, they are excellent sources of inspiration for my game design. As I mentioned in the last devlog, I'm using a modular design, so I can create more and bigger levels with fewer assets. The problem with modular design is the lack of variety and repetition, something I want to avoid and disguise at all costs. Taking advantage of the February sales in the ArtStation marketplace, I bought two tutorials about level design to see what tricks the pros use to overcome my challenges. One of the tricks is using materials with textures that affect the entire world without considering the UVs, something similar to the tree-planar projection. This is super useful to break the repetition of textures in modular assets because it uses the position of the asset in the world instead of the position of the vertices in the UVs. Another trick is blending different materials with vertex painting. This requires more manual work as it involves manually painting the level, but it can be useful to create a second level of detail. So for the moment, I am finishing the general texturing of the assets. I made my materials with dirt that affects the assets globally, and then I will do a second pass with the vertex painting and assets to dress up the level. The last thing will be to work on the lining and moon. So far I'm pleased with the result, and it will be very exciting to see the level come to life when I put all the pieces together. In a previous devlog, I commented on using narrative for my quests and dialogues. And although it is a fantastic plugin, as usually happens with this kind of tool, they are developed to fit the vast majority's needs, which causes limitations, unnecessary complications, and features that we may not need in our project. After using narrative for a while, I created my own solution. My quest system is now simpler and adapts 100% to my needs. My system includes different types of quests like gathering certain items with or without minimum quantities, reaching a location, eliminating an enemy, etc. And the quest can include subquests. I have created the UI and all the notification systems for the new quests, and when we update or finish a quest, and the quest log to track its status and get more information. In addition, the system also allows giving quests through dialogues. Finally, I have created two systems that are essential for any game and that are intertwined with the rest of the systems. I'm talking about the save and localization system. These two systems always scare me because of their complexity. I'm glad I added them early in the game's development because although they are not extremely complicated, they are complex in managing variables and languages. By integrating it now and adding the translation on the fly, I will avoid making a massive refactor at the end of the game. Currently, only for testing, I use the L key to switch from English to Spanish and vice versa. And the translation is done live without needing to reload the game. Everything is managed from a function in the game instance that calls the translation in a data table. Every word printed on the screen, whether in the UI, in a dialog, or in a menu, must be linked to a row in a data table. My advice is not to leave this for the end when the game is already fully developed, because you will have to look for each word in your code and replace it with a call to the data table. If your game is minimally large, leaving something untranslated will be very easy. As for saving and loading, my system allows saving the progress of quests and the state of the world. So if we collect an item, when we return to the level, that item will no longer be available. Or for example, as you can see here, if we lower the bridge, when reloading the game, the system recognizes that we had lowered the bridge and it will show it lowered. The save system will be automatic with any event involving a significant change. For example, the state of a quest, a conversation, or an action that modifies the state of the world. And finally, I had to refactor the inventory. My inventory was working with structs to store the information of the items. But when I modified the struct, the whole system broke. I had previously read people complaining about the struct system in Unreal and how it had broken projects. But it had never happened to me. So to avoid future problems, I decided to change the information management. Instead of structs, I now use blueprints. The blueprint not only stores the item information, but all the graphical information. This is a solution that has some drawbacks. But on the other hand, it also has its advantages, because now I only have to hide or show the items instead of creating and destroying them, which is more efficient and generates less garbage collection. My game now only uses structs for localization, and that's essential to be able to use the data tables. So I hope it won't give me problems when I modify the structs to add more languages. Fingers are crossed. And that was all the development so far. I hope you liked the update. As always, thank you very much for watching and see you in the next episode. Bye bye!